the Kaya identity. The Kaya identity is an equation that was created by Yoichi Kaya that helps us in two ways. It's a helpful thinking tool for the four main drivers of overall carbon dioxide emissions from the energy sector. Secondly, it's a view here in En-ROADS. Under view, Kaya graphs that we can look at to figure out what's going on with the drivers of CO2 emissions in the model. The basic equation is this. It says that these four factors here in these graphs multiplied together equal the fifth. That is global population times the GDP per capita per person times the energy intensity of GDP times the carbon intensity of final energy use. Those things multiplied by each other equals CO2 emissions from energy, the fifth factor. Let's look at each one individually. Over on the far left, global population, 2000 to 2100. It's growing slowly. Its rate of growth is decreasing over time as we have falling fertility rates, more industrialization, and around the world, smaller families. That number is multiplied against the next one, which is the GDP per capita. This is overall consumption and growth around the world, more goods and services. It's measured in dollars per person per year, growing at about 2.5% a year in the near term, slowing down to 1.5% a year. Multiply those two factors together, population, GDP per capita, you get overall GDP. Go look at the graph if you like. Overall gross world product. That's the two first factors multiplied by each other. Okay, now the third factor is the energy intensity of GDP. How much energy does it take to deliver $1 trillion of goods and services? It's measured in exajoules per $1 trillion of GDP. You can see that it's falling steadily over time as the global economy shifts from manufacturing towards service, but also as technologies like cars and buildings and motors get more efficient over time. Multiply these first three factors together and you get the total energy use on Earth. There's more growth than there is a decline in overall energy intensity, so the total is going up. Let's go confirm that. Energy demand, actually, this graph on the left, is actually going up. Okay, so now we multiply the first three together, we get total energy use. Multiply it by the fourth factor, the carbon intensity of final energy. That is, how much carbon dioxide gets emitted per unit of energy. The units on that y-axis here are megatons of carbon dioxide per exajoule of energy. Decarbonization is this trend. As this falls, that is what we call decarbonization. There's less carbon in the overall energy economy. It's falling over time as we have relatively less coal, oil, and gas, relatively more wind and solar, and some more nuclear. Overall, it's falling over time. So take those first four factors, multiply them together, and you get the fifth, carbon dioxide emissions from energy. It's also just a helpful way, really simply put, what can we do to change CO2 emissions from energy? Well, with this framing, you can have fewer people, less consumption, more energy efficiency and conservation, and or decarbonization. More wind and solar, less coal, oil, and gas, less fossil fuels. These are the four main intervention points. And of course, all the sliders and En-ROADS will touch upon different ones here to give you this result of CO2 emissions from energy. Now, it doesn't include, this equation, of course, doesn't include carbon dioxide emissions from deforestation. It doesn't include carbon dioxide removals. It doesn't include methane. It doesn't include F-gases or nitrous oxide. But it's a really helpful way to look at the main four drivers. I often use it after I've made a bunch of changes. Say you've done this and some of that and other actions, and you're like, what's going on? You can look at this view and see, what has changed, what hasn't changed to get me the result that I'm getting right now. And it might actually be a guide towards what next might be needed in order order to get down to the goal of 2 degrees. Okay, so the Kaya identity, a helpful way to think about the main drivers of carbon dioxide emissions from the energy sector, but also a very helpful view to figure out what's going on in the scenario that I've created. I hope this was helpful. Go get them.